Hey there. Today we're going to talk about some properties of logarithms. And knowing these properties is helpful because without these properties, we are limited in what we can do in solving exponential and logarithmic equations. And these will allow us to do a lot more with those types of problems when we get there. So we're going to start by looking at the product rule for logarithms. And in order to introduce it, we're going to refresh our memory as to what is the product rule of exponents. And you may recall that you learned something along these lines in a prior math life. So b raised to the m power times b raised to the n power. Do you recall that when we do this calculation, we keep the base and we add the exponents? So that would result in something like b to the m plus n power. Okay, so there is something analogous to that in logarithms. And that kind of looks like this. I'm going to slide all the way up. If I have a logarithm with a base of b of a product m times n, then I can break that logarithm up into two different logarithms and they are summed. So this would be equal to the log base b of m plus the log base b of n, okay, if I were to break those apart. So that allows us to take things that are a product already and break them apart and simplify them, or we can take things that are broken apart and put them together as a product. So it depends on which way we are going. But we're going to start with some examples, very simple examples that apply this rule. So let's start with this example. Log base 3 of 7 times 3. Okay, so we could take this and apply this property, and we can say, well, that is equal to log base 3 of 7 plus, log base 3 of 3. And we know that this logarithm simplifies. Log base 3 of 3, well, 3 to what power gives us 3? Well, that is the same as just 1. So log base 3 of 7 plus 1. Okay, so that gives you an idea of how we would use this property. So let's do a couple more. We're going to look at log base 9 of 9x. Okay, so taking that property, we're going to break this apart into two different logs. Log base 9 of 9 plus log base 9 of x. And then I look at both these logs and I say to myself, I think one of these may simplify a little further. This one does not. But this has log base 9 of 9, so I'm thinking of what power of 9 gives me 9. Of course, that is 1. So we have 1 plus log base 9 of x. Okay, so let's do, we got two more examples. We have log of 10,000x. Okay, and recall that when you don't have a base written, it's assumed to be 10. So we can say that this is the log of 10,000 plus the log of x. And this will simplify. Log base 10 of 10,000. 10 to what power gives us 10,000? That would be 4. And our last example of this rule would be ln of 12e. Okay, using that product rule, we're going to break it into two logarithms, ln of 12 plus ln of e. And of course, ln of 12, that's log base e of 12. That doesn't simplify at all. But this ln of e, log base e of e, that gives us a nifty number 1, ln of 12 plus 1. Okay, so that in a nutshell is the product rule of logarithms. Happy calculating.